Hello, welcome to video lecture 3. We're going to be starting chapter 7, and yeah, just want to walk you through it. This is going to all be about what we are calling rational expressions. And rational expressions are basically just a quotient of two expressions, something divided by something else. So, for example, um, something like x squared over 2y squared. That's a rational expression. You have an expression on the top divided by an expression on the bottom. And that's all the name means. It's just something divided by something else. So don't let that really get you caught up too much. So let's look at the first one that they give us here. And they want us to simplify this rational expression. So in order to simplify this guy, we need to cancel out as many common factors as we can, right? So similar to how when you're dealing with a fraction and you say you have something like 112 divided by 214. Let's say 216. 2016, wow. That's supposed to be 216. Let's say we're trying to simplify this, right? Well, we could say, okay, well, 112, well, we can definitely factor that out into 2 times 56. And then we could also factor this guy into 2 times 108. Why do we do that? Because now we can cancel out these factors of 2. Because 2 divided by 2 is 1, and the 1 multiplied by anything is just the same thing, so we can cancel those guys out. We can keep doing the same process, right? We can turn 56 into 2 times 28. We could turn 108 into 2 times 54, cancel out those common factors again, and you just keep doing the process. 2 times 14 over 2 times 27 cancel out, and then we reach a point where there's no more factors to cancel out, and we're done. Well, we're going to be doing the same kind of concept here, except for we're going to have variables thrown into the mix. But we're going to keep canceling out common factors on the top and the bottom. So the first thing is 6 and 18. Well, I noted that a 6 can go into both of these, so let me just go ahead and do divided by 6 divided by 6. Well, 6 divided by 6 is just 1, so that's going to go away. 18 divided by 6 is 3. So far we have u to the 4th v squared over 3u v squared. And I'm just rewriting it to show you that the 6 over 18 became 1 over 3. And I just got rid of the 1 there because it doesn't really do anything, right? That 1 is implied. So now we go on to the u's. Well, I have u to the 4th over u to the 1st, right? Even though we don't have it written there, how many u's do we have? 1. So how many u's can I cancel out? Well, you ask yourself again, how many u's do they have in common? Well, just 1. So guess what? I can cancel out 1 u from the top, 1 u from the bottom. So if I take away a u here, instead of u to the 4th, it becomes u cubed. Alright, pen wants to be a little finicky. And then u to the 1st, if I take away 1, that's just u to the 0, so this is just gone. And what about here? Well, they both have 2 v's, so I can take away 2 v's here and 2 v's here. And what am I left with? U cubed at the top and 3 at the bottom. And that would be my answer. And so we're going to do the same process over here, right? We're going to say, okay, what common factors between 28 and 35 that we can cancel out? And the answer is 7. So let's divide this by 7 and divide this by 7. 28 over 7 is 4. 35 over 7 is 5. What about the u's? Well, it's 3 u's and 4 u's. Why don't we take away 3 u's from each spot? So 3 u's from the top leaves us with no u's. 3 minus 3 is 0. If we take away 3 from here, we get just 4 minus 3 is 1. So this is just the u by itself. And then same deal here, v over v. Well, that's v to the 1st over v to the 1st. If we take away a v from the top, we take away a v from the bottom, there's no more v's, and we're left with 4 over 5u. And that would be our answer there.